This chapter is about the Ethernet in VM network. Ethernet in VM network, yes. How Ethernet, the virtual Ethernet or VNIC, it's not VMNIC, it's VNIC, how it looks like and so on. So this is how we actually get Ethernet in the VM world. We have a virtual switch. This is a virtual switch. This one is a virtual switch, and this is the actual host with the physical NIC cards. We call this as VMNIC. This is VMNICs. All the physical cards are called as VMNICs. And this ports that we get here on the virtual switch is VNIC. And these are all virtual servers. Now this virtual servers are connected to this VNIC ports, and traffic that is going to these VNIC ports are sent to this VMNICs, and from this VMNIC it goes to MDS, or it goes to a 5K or 7K, or it can be a normal routing device also. Need not to be always a Nexus switch. So this is how the virtual environment, the virtual access layer, we can call this as virtual access layer. This is virtual access layer, and this is physical access layer. So virtual access layer are extended to the physical network environment or invisible to the standard networking tool. So this is the story that we are learning from the beginning. What's the problem with the VMware? There is no visibility for the network admins. Here, not only network admins, even the networking tools. Networking tools comes right up to here. That's all, it stops. There is no visibility inside. That is what we were seeing from the previous class. Now this is how the access layer, virtual access layer will look like. This is a virtual switch, and we got two NIC cards here. See, if you go to vCenter or vSphere client, you can see this. Two NIC cards and two physical NIC cards, or we can also call it as VMNIC, and then these are all VNICs, and these are all the servers connected to those VNICs, and we got two port groups. So virtual access layer, a series of virtual switches, servers, and network interface residing inside a VM, ESX or ESXi host. So this is one host having one virtual switch. You may have many virtual switch inside one host, or you can have one host with one virtual switch. Likewise, we can have many hosts bundled together as a cluster. Then we will have group of virtual switches. With the help of virtual distribution switching, we can do that. It's coming anyway in the following slide. Virtual distribution switch or distributed virtual switch, which will group virtual switches together as one cluster. That's what we call as DVS or VDS. Even Nexus provides the same VDS, virtual distributed switch. So this is how the virtual access layer will look like. Allows the sharing of physical interface. This is the physical interface between the virtual machine. Physical interface resource between the virtual machine. This virtual access layer. Now, what is the feature? It's a layer 2 Ethernet switching, virtually done, and it supports even VLAN segmentation, and only outbound rating limit. Rate limit can be done only for outbound traffics, not for the incoming. Only the outbound traffic that are sent out. Rate limit can be done. VLAN can be assigned in 3 different ways. We will see what are the 3 different types of VLAN assignment in coming slides. And then it provides a layer 2 switching environment, virtual access layer. Now virtual switch also supports this thing. So we can see here the virtual switch is lying, here, the blue bar. The hypervisor is here, the physical NIC card is here, and then the virtual NIC cards, VMNICs are here. Sorry, VNICs. This is VMNIC. This is a physical card. Now this virtual switch supports VLANs. We can assign VLANs, but who assigns? It's the VMware admin, not the network admin. So vSwitch is not Nexus 1000, like its VDS is also not, or VDS no, ESXi, this VMware people called as DVS, distributed virtual switch. This is also not Nexus 1000, and vSwitch and DVS are not the same, they are separate, but they can run parallelly. But there is no meaning in running it parallelly. They can run parallelly. vSwitch is different, VDS is different, or DVS, distributed virtual switch, is different, and these two are ESXi byproducts by VMware. First VMware ESXi came with vSwitch, and then they said we can cluster the vSwitches. That brings distributed vSwitches, distributed virtual switches. And there are some drawbacks in both. That's why we have 1000V. 1000V is Nexus iOS, Nexus Cisco product. But one important thing is, for 1000V, this DVS, distributed virtual switches, mandate. Nexus 1000V depends on DVS. No DVS, no 1000V. So in order to understand all these things, foundational thing, we are going step by step. Now, what's the problem with virtual switch? Virtual switch is not having big problem. It looks like a very cool feature, like we have VLAN support, we have NIC teaming, we can group the NIC cards together, we even have packet shaping for load balancing. All these are available. So vSwitches are composed of virtual ports associated with physical and virtual network interface card. So here we see virtual interface card, VNIC, and we have physical card, VM NIC. In the middle we have vSwitch. So vSwitch has got two components, one is VM NIC, another one is vNIC. Outbound traffic is load balanced across available physical network interface card. Only the outbound traffic. So outbound traffic can be load balanced. Multiple vSwitches can be configured on a single server. This is not talking about cluster. This is not talking about distributed virtual switch. This is saying we can have more vSwitches on a single physical box, on a single ESXi host. We can have many vSwitches like this. More VM machine we install, more ESXi host, ESXi VMware ESXi we install, we get more switches. Or more vCenter client we install, we get more vSwitches. So vSwitches consist of more advanced functionality, like even it supports CDP. vSwitches even it supports CDP. It supports outbound traffic shaping. Only outbound. Not only that, it can be configured with no outbound NIC. Why? Meaning I need not to have any NIC cards. Even if I have, I will not select those NIC cards. I will not include when I want to restrict the external communication. If I want only to talk between these VMs, I do not want to go outside to the internet world, then I can have without a NIC card, without a physical NIC card. Still, these will work as if it works in a LAN switch. These VM machines will talk each other. Only thing is they cannot talk outside because there is no outbound NIC. Let me show you in the diagram. So here we see that there is no adapter. There is no physical adapter. So it is possible. If you don't have a physical adapter, here we have physical adapters for this vSwitch 1. For vSwitch 0 there is no physical adapter, which means this vSwitch 0 will talk only like this. They do not talk outside. They can talk like this also, between one vSwitch to another vSwitch. Through VMware software they can talk, but they cannot talk outside like this because there is no physical adapter. If they want to talk to this physical adapter, if they want to talk to the internet, they can come like this and they can go. They can come from one vSwitch to another vSwitch and they can go like this. Alright, so let's get back. Yes, sir. Yeah, it should be in same physical device. Yes, that's very important. They should be in same physical device. We can have multiple vSwitches in one physical device. That is vMotion. That is different stuff, sir. That is overall chapter. The chapter was covering overall Nexus 1000 V. So there we saw even those things which we are going to learn tomorrow as an introduction there. That is distributed switch. That is even after vSwitch we are going to learn even in ESXi we have a distributed virtual switch, where we have each hardware machine having a separate ESXi, and we cluster together. So what did I say yesterday? Yes, so we can have multiple switches in a same host, multiple V switches in a same host. We can also have multiple switches on different hosts clustered together, but that cannot be clustered by V switch. That's why we go for the next version, distributed virtual switch. And we can say the third version like 1000V, because even DVS has some limitation. That's why we go with 1000V Nexus. What's the limitation? We already know that the visibility can be provided only by Nexus. Okay, now so there need not to be an outbound NIC card. If you want to restrict the external communication, don't add a NIC card to that V switch. If V switch has no NIC card, then it is local. Only VMs can talk each other. Right. It also supports trunking. It also supports trunking, meaning here you can have trunk so that it can carry the VLANs, multiple VLANs traffic. Consists of one or more configurable port groups. So we can have more port groups. As I told yesterday, we are not going to configure anything under the interface. The reason is this is not physical interface, and these are all VNICs. We don't go and configure. We don't say virtual interface fast Ethernet 0/1 port security. We don't do that. Now we create port groups, and we'll have a port profile to add to it, and whichever the interface that joins that group will take the profile. That's how the vMotion is possible in VDS. When we move one VM from one machine to the other machine, from one physical machine to the other physical machine, it's not possible through V switch. I'm talking about VDS. When we move that, we don't still lose any profile. So here in V switch we have port groups. One for VM communication. This will be in a separate VLAN. Another one for communication between the kernel. That's for management. Another one. Okay, this is for management, and this is for VM kernel and physical network, and this is for VM communication, virtual machine traffics. So you have three different port groups: one for the system, one for the management, one for the VM traffic. So three port groups: one for the traffic coming out from this VM communication. That's one port group. Another port group for the system to interact each other. The other one for us to do SSH or Telnet or so on, to manage a few Linux based commands we need to know to do that for that. So if you see the communication, there are three different types of communication needed here, and all these three will be in different VLANs, and they belong to different port groups. Each port group must belong to a single VLAN. They need to be in a separate VLAN. This, three need to be in separate VLAN. VMs are assigned to port groups. So VMs, let's say these three are VMs. they are assigned to VLAN 30, and this one is for let's say for kernel VM10, and this is for management VLAN 20. Because this is a virtual switch, we don't have a separate port called console port. No ports. There is no port for the internal communication to happen, because if you have multiple V switches, they need to communicate from one V switch to another V switch. So there is no port actually. We have to assign this VM NICs to different VLAN, and we need to put them for purpose. This VLAN is for VM communication. This VLAN is for kernel and physical network communication. This is for the management purpose. So we have to assign it. It's a good practice to have in a different VLAN. If you put in the same VLAN also, they work, but it's not really good. So each VM must belong to a single VLAN. VMs are assigned to the port groups, configured and managed in a software by VM administrator. So as I told, these ports are not physical ports. These are all virtual switch ports. So definitely it has to be controlled by a software. That's what vSphere client. With the help of vSphere client, we configure and manage these port groups and assigning VLANs and so on, configuring trunk and so on. Now here what we see is a switch, a V switch, and ESXi1 and ESXi2. V switches are configured on each VM's ESXi, so they have to be configured separately. Here I have a V switch and we have another V switch, and there are two VMs are running on it. Here also two VMs running on it, and we got two physical NIC card, and we got this many set of VMs, PCs, 1, 2, 3, 4, 5, 6, 7 VM machines. So here also it is identical. Now they have something to teach here, but here the PPT is not clear. Here what they come to say is one or more V switches can be configured, but they need to be configured individually. We don't have any group configuration. This has to be configured separate, and this has to be configured separate on each ESX host. So if vMotion or a cluster is used, each participating V switch must be identified as an identical configuration, meaning the configuration need to be more identical. So this is one physical machine, this is another physical machine. We need to configure separately. We cannot group these all together. We cannot group all this together and configure as a group. That's not possible. And it needs to be identical if we are looking for vMotion. It needs to be identical. The number of VNICs should be identical. Even somewhere I read even the process speed should be identical. But it's not mentioned in our book, but somewhere I read even the process speed of these two hosts need to be identical. If someone says the NIC card speed should be same, then okay, I agree. But I don't know why process. So this has to be done manually on each host if we want to cluster it. So what does port group means? What port group means? port groups are configured on a vSwitch. Where do we configure port group? We configure on a vSwitch. So here we see group number 2, group number 1. Port groups are configured on a vSwitch. Now this is the same pictorial representation you will get on a VMware. That's why it is shown. This is not some imaginary diagram to explain things. This is the output that you will see on a VMware. When we configure VMware, this is the output that we will get. This is how you will see and confirm whether things that we want is there or not. That's why the picture is same in previous slide and before slide and this slide. VM group, it's configured on a vSwitch and it is used to segment traffic. It is used to segment traffic for kernel, separate traffic, for service console, separate traffic, for VMware traffic, separate. So in order to put them in different track, not only VLAN, we also need the port group. Only through port group we can say what VLAN this VM kernel belong to, service console belong to, VM traffic belong to. So we don't do anything on the interface because it's not physical interface. We just create port groups. Who creates port groups? Actually, it is the network admin. That's the final conclusion we will have in this course. Network admin does all the network related thing and gives to the VMware admin. If Nexus 1000 or if Cisco didn't interfere in this, it would be a big burden for the VMware or system admin to do this. They don't understand these things much, like what VLAN is and how to put them separate, why we need to put them, what is traffic engineer. They don't know anything much like a network engineer, so it would have been a big burden. So port groups are configured on a vSwitch. As for now, Nexus has not come. As for now in this slide, we don't see Nexus switch. We see vSwitch, so it has to be done by a VMware team. The reason why we have port group is to put the different traffics in different treatment, like providing VLANs. So this is configured by a VMware or server admin. Initially it was like that because it is only vSwitch, it's not Nexus. So this is how they configure GUI. Through GUI only they configure the security, if they want to give, if they want to do traffic shaping, if they want to group NIC cards. We call it as port channel in our language. The Windows people or VMware people called as NIC teaming, grouping the NIC cards. Same like Ether channel. So all these things were done by a VMware or server team through a GUI. Now vSwitches are created inside each VM ESXi host and managed as a separate virtual network. So they are separate. They are totally isolated from the physical network. They are managed separately. So there is an administrative boundary. Network team cannot see what is there behind the hardwares. So there is an administration boundary. Only the server team needs to take care of all this network related configuration on a virtual environment. This was the barrier, this was the boundary. Now VMware vSphere operates in a similar fashion as a physical layer switch, meaning in layer 2 switches we have MAC address learning. Likewise here also MAC address learning is there for VMs. Forward frames based on layer 2 information, meaning using MAC address. Each VM has virtual MAC address. Based on that the packets are being forwarded, and it maintains the MAC table, same like a normal physical layer 2 switch. This also maintains a MAC table. Now right, so it supports the internal switching for VMs. So using the MAC address they communicate between the VMs. It can even tag frames with VLAN ID using 802.1q, a trunking protocol. So it can even tag frames. The V switches can do this, and can support port channel for active NIC teaming only. So there is active standby and active, but it supports port channel only if all the links need to be active. One active, one standby, no. So these things are supported. Learning MAC address, forwarding packet based on the MAC address, same like a layer 2 switch. Assigning or tagging VLANs, support for port channel. Okay, this is the configuration limit. Multiple V switches per VM we can have. On a single host we can have multiple V switches. Up to 1016 virtual ports per V switch. It's really a very big number. For this really we need to have a very big server. 1016 virtual ports, meaning you are trying to have 1016 VMs. If you even take 2 or 3 virtual ports for management, so more than 1000 VMs, then we need to provide 1000 virtual processor memory. That's not possible. But the limit is not really less, it's really very big limit. Up to 1016 virtual ports per V switch. We can have multiple V switches in a VM. Each V switches can support up to 1016 virtual ports, and up to 32 VM NICs can be binded to one V switch. So like this, physical switches, physical NIC cards can be 32. Like this, VNICs can be up to 1016. This is VNIC, this is VMNIC. So this is really a very big, this cannot be said as limitation, this is the max. V switches, the MAC address table records the MAC address and the port number for VMs. So frames to unknown MAC address are forwarded to the physical NIC uplinks. So this VM MAC address they learn and they maintain in this switch, the V switch. But because there is no visibility from outside to inside or inside to outside, there is no MAC address for outsiders. So what this will do, for if the destination is unknown, if there is no MAC address for the destination, it will send it through one of the physical NIC card. Very important, one, it's not mentioned here. The frames to an unknown MAC address are forwarded to a physical NIC card NIC uplinks. If I have multiple uplinks, if I send it via multiple uplinks, what will happen? If I have a switch connected like this, physical switch, loop will occur. So it is not going to send out through all the physical NICs. It is going to send out through one of the physical NIC if the destination MAC address is unknown. So frames to the unknown MAC address are forwarded to physical NIC uplinks, physical NIC card. If the MAC address is known and if it belongs to a local VM group, it sends to VM machine. If there is no MAC address, then it's not from VM, it's from outside, so it sends through one of the physical NIC. Yes, sir. Yes, you're right. Yeah, which uplink it will use? It's coming in the next slide. It's coming in the next slide. Yes. Right. So how the loop is prevented? We should just do not participate in spanning tree protocol. Then how it is going to prevent the loop? Loops are prevented by passing outbound traffic on only one physical NIC at a time. So there is no active, there is only active passive. So active passive NIC teaming only the active link is used. So if you have two link, one is active, another one is passive. So only when the active goes down, the passive is going to pick up as an active. So only by using the active link it will send it, regardless of port group. See, there is no MAC pinning or something like that. Maybe in an advanced concept we will be learning MAC pinning. That's not here. What is that? Traffic coming from this group will use this particular NIC card. Packet coming from the other group will use this NIC card. No, that is MAC pinning. That's too far from our current syllabus. So definitely we will be learning those things in coming days. But here this is talking about vSwitch. We have two NIC cards. Only one is active, the other one is passive. So using the active NIC card, the frames will be forwarded. Only the active link will be used. So if we have active NIC teaming, each VM utilizes only one uplink at a given time. So the time matters here. At what time it comes and which is active that particular given time. That link it sends. It is not going to send through both the link. It's not going to send even if we have both active NIC teaming, it is not going to send via both the links. It is going to send via one of the uplink which is active at the given time. vSwitches does not flood frame like a normal layer 2 switch. Normal layer 2 switch, if the destination is unknown, it will flood. vSwitches, they don't do that. They send it via one of the physical interface outbound. By doing so, it prevents loop. vSwitches cannot be connected to one another. vSwitches cannot be connected to one another. Means vSwitches, they cannot be connected to one another. Two port types are supported. What is this? This is not complete. vSwitches. One minute. vSwitches cannot be connected to one another. Two port types are supported: VMNIC and VNIC. So without the help of the ports, they cannot talk each other. That's what this really means. V switches cannot connect to one another without the help of VMNIC or VNIC. There are two types of ports that we see. There is VMNIC and VNIC. That's what it really means. Without help of port, they cannot communicate. Either VNIC is needed. If I have V switches on the same host, if I have V switches on the same host, if they need to communicate, definitely there should be a VNIC. There should be some sort of connection, logical connection between these two. If it needs to talk to the other box outside, then it needs to come through the physical NIC. That's what this really means. V switches cannot be connected to one another without any one of this help. Yes, sir. Okay, so you're asking like V switches on same host. Don't worry, sir. The example is coming. Yeah. Now NIC teaming. NIC teaming is nothing but ether channel, but here we call it as NIC teaming, grouping the NIC cards. You can have in two fashion. Active passive or active active. Active active is for load balancing. Active passive is like one will be active at a time. So if active goes down, the passive will become active. That's for the failover scenario. VM leverages the NIC teaming for physical NICs in order to provide fault tolerance and performance benefit. VMware drivers and software provides NIC teaming. So we don't need a special software. It is inbuilt in VMware. By using that, we can do NIC teaming functionality with no vendor software required. But there are some third-party software available, but it's not really needed. So two teaming configurations. Configuration type, one is passive active. Another one is active active, which is for load balancing. Now they are identified by, the load balancing is done by any one of this. Based on the VM port ID, we can do load balancing. Based on the MAC address, VM MAC address, we can do the load balancing, or based on the IP address, source and destination IP address. Same like layer 2 switch. Even in layer 2 switch we do the same. But only thing is here VM comes there is no VM. So load balancing in ether channel, how we can do? We can do based on source MAC address or destination MAC address, or I think even the port ID comes there. I need to check, but we do based on source destination MAC address. We do based on source and destination IP address on an ether channel supporting switch. So likewise here also load balancing can be done using any one of these three. Now VLAN tagging. Switches support 802.1q tagging method. This V switch supports 802.1q. It supports in three different ways. One is external switch tagging, EST. External switch tagging is nothing but this VM switch will not do anything. V switch will not do any tagging, but it allows the physical switch that connects to them to tag and send. Frames are left untag. V switches, they don't tag. and any tagging occurs in the physical network. So they accept the tag that is done by the physical network. So this method leaves the frame untagged and allows the external switch to handle all the tagging mechanism, tagging operation. So external switch takes care of tagging. That we call it as EST tagging. External switch tagging. It's meaningful. External switch tagging. So it allows the external switch to handle all the tagging operations. What is this VGT? Virtual guest tagging. So who is guest here? The VM is the guest. Virtual machines are the guest operating system. Now if the V switch will allow the operating system itself, operating system on the VMware, to tag and send the traffic, then we call that as VGT, virtual guest tagging. This method allows software within the guest operating system to tag the frame and maintain that frame within the virtual network. That is VGT. There is third tagging mechanism called VST. So this is like, the switch itself tags. Virtual switch tagging. And this is the preferred method as well, so that there won't be a conflict. Only on a switch we configure virtual switch. So 3 different types of taggings: EST, VGT and VST. So virtual switch security. Now in this topic, the question that you have will be answered. An example for virtual switch security will answer our question, meaning communication between 2 virtual switches in a same host. Now virtual switch security option. Virtual switch by default virtual switch security option by default is Prometheus. What is Prometheus? Even though the virtual VM machines are in same VLAN, they are not allowed to talk each other. It prevents VMware from seeing unicast traffic. Okay, this is, sorry, I made a mistake, sorry. What is this Prometheus mode? Prometheus mode is default. What it does is, it is not going to allow traffic to reach some VMs to which the frame is not intended, meaning it prevents VM from seeing unicast traffic not intended for the port MAC. Meaning, if a traffic is coming from this, let's say the MAC address is A, B and C. If packet is going from A to C, it will not allow B seeing the packet. That's what Prometheus mode. It won't allow B looking into this frame. Prometheus mode enabled by default. Prometheus mode prevents VM from seeing unicast traffic not intended for the port virtual MAC address. It prevents the packet that is not intended for the virtual port MAC address. And then what is this? That's what Prometheus mode. That is one type of VM security. The second type of VM security is MAC address change lockdown, meaning it will not allow anyone to change the MAC address manually. Prevents VMs from changing the assigned virtual MAC address. So it's like statically binding the MAC address to VMs. It won't allow a new MAC address. It won't allow MAC address to be changed. Because it's in a VMware, we can change the MAC address. It won't allow if it is MAC address change lockdown. Option is selected. That's second security. Third one is frogged transmit blocking. What is this? If it is coming from different network, that is what frog, jumping. It prevents VM from sending frames that appears to come from another node on a network. Another node on a network means, it won't allow communication between one node to the another node. It prevents VM from sending frames that appears to come from other node on a network. Ensures that VMs are not able to send frames that appears to come from other network nodes. So 3 different types of security options we have: Prometheus, MAC address change lockdown, frogged transmit blocking. Now this is how the configuration of this interface will be. This is not the configuration on a V switch. Upstream port configuration on a Cisco switch. This is a normal Cisco switch. So how we will have configuration on here? We'll say trunking. We'll enable trunking. Means trunking protocol. First we will say what .1Q or ISL. .1Q is what now we see. There is no ISL. ISL is removed. And we need to turn on the trunk, and we need to say the mode. Oh my god. Either this or this. Switch port mode access or switch port trunk mode. Any one. Not both. So we turn on the trunk and we enable port first. Port security is not recommended. We saw in the previous slide, port security is not recommended on the physical box. Maybe on the V switch we can have port security. Not needed here. Why port security is not recommended? I want to explain why port security is not recommended. Why they say don't do port security on the physical interface. When I enable port security, the default number of MAC address allowed is only 1. Let's say I'm saying allow 10 MAC address. Now I'm having 10 VMs. 10 VMs will give 10 MAC address here. No. It will give sometime 11 MAC address. 10 VMs. It will give 11 MAC address. How? One MAC address is to identify the V switch. Now what will happen? The port will go to error disabled state. Maybe it will shut down, or it will go to some error disability state. By default it will shut down if one extra MAC address comes. So to avoid this confusion, it's not really recommended to have port security enabled on this physical uplink ports. Right, VM port groups. There are 3 types of port groups, as we already discussed this. One for the kernel, which supports vMotion and IP based storage. Another is for the service, like we do SSH or so on. For that, another port group. Another port group for the virtual machine traffics. So here we see there are 3 port groups. One is for service, another one is for the VM machine. We don't have any vMotion or anything here. This is just a normal V switch, so we don't see here VM kernel on this example on the left. And we also see that there are 2 dedicated VM NICs, the physical NICs given for the service, and there are 4 VM NICs given for the virtual machine traffics. So recommended practice: separate physical NICs. It's recommended to give separate VNICs so that the traffic will not be disturbed for each groups. So this answers one of your previous question. We can map separate physical NICs for each groups. That's recommended. Separate VLAN for each port groups. Separate NIC, separate VLANs. Right. So vSwitch configuration options. vSwitch can be configured with 0 to 32 NICs. As we already saw, if you don't have any NIC, 0 NIC, communication is not going to go out. It's local. So we can have up to 32 physical NIC cards. We call it as VM NIC for outbound communication. 0 means no outbound communication. VMware NIC teaming is used to load balance traffic across the available link. We already saw it supports active and active passive, and load balancing can be done based on port ID, MAC, as well as IP address. Internal only vSwitch can use for, okay, what is internal only meaning? If I have 0 as a number, there is no VM NIC, then it is internal only. Why someone will have internal only vSwitch? This is internal only. There is no physical NIC card. No physical NIC card. 0 physical NIC card. That is internal only. Why someone will do that? For testing between these VMs. So this, while testing, it should not affect the existing network. So we isolate. We remove all the NICs and we do testing. We isolate. So VM can be remotely accessed through VMware tool. Yes, this is another one which gives the answer for your another question. VMs can be remotely accessed through VM tools even with no outbound uplinks, without any physical link. Just by using VM tools, VMs can be remotely accessed. Now one example is coming. This is the example. Now what we see here is a logical flow. There are 2 vSwitches. And physical card is not connected to this vSwitch. Not. It is connected to only to this vSwitch. Now this VMs can still go outside by going to this firewall, and firewall will check whether this traffic is eligible to go out. If firewall allows, then it goes like this. Same for incoming traffic. Firewall checks, sends. This is logical flow. How the physical configuration? Physically it is like this. There is no NIC card, no adapter for this VLAN, let's say 10. No, here VLAN should be same. Whatever. So for this V switch. This is switch 0, this is switch 1. For this V switch, we don't have any adapter. For this V switch 1, we have 2 adapters. This is the same diagram which we saw previously. And these are all VMs. This 4 VMs. And this 4th VM is in both the groups. That's the secret. The 4th VM is in both the groups. So this is possible. Communication between switches through VM software. So this answers your question. Let's go back and read this. Software firewall applies, so we can even have firewall on vSwitch. Software firewall appliance and the router can be used, even the routing device can be used, software routing device can be used within the VM to create a secure internal network or demilitarized or DMZ zones. This we saw. Let's read. Adjacency. So what's needed? Okay, that story is over actually here itself. So this is the logical flow, and this is how virtually it is configured. I cannot say physical, virtually it is configured. Next, layer 2 adjacency. VM advanced functionality requires layer 2 adjacency for kernel ports. So adjacency need to be done between the switches for high availability, for distributed resource scheduler. Yesterday we saw DRS, distributed resource scheduler, and for vMotion. The adjacency between the layer 2 device is needed. This is talking about 2 switches in 2 different VMs. Yes, this is talking about 2 switches on 2 different VMs. So there is a need for an adjacency between 2 switches. That is where comes a new type of switch called DVS. In the previous case, it was not between 2 different hosts. It was 2 switch within the same host. This was 2 virtual switch within the same host. Now, when I need vMotion, or if I want high availability, meaning if one switch goes down, I want all these VMs to be active through this switch. Sorry, this is not the outside world. Active through this switch. Now this is the vCenter which controls all this, manages all this. It's a vCenter machine. It's a VMware machine which manages all this. So if you want to centralized management, if we want centralized management of V switches on different hosts, this is one computer, this is another computer. Then all what we need is something more than V switch. That something more is what called as DVS, distributed virtual switch. So distributed virtual switch, what it gives is it gives a centralized management. So with the help of vCenter, we can control V switches on various hardware hosts. These are all separate ESXi, separate physical host. So using the VMware distributed virtual switch technology, multiple switches within a cluster, this is one cluster now, can be configured from a central point. The distributed virtual switch automatically applies the change to the individual switch on each VM ESXi host. So in the previous case, we saw that each V switches need to be separately configured in V switch we saw. But here what we see is V switch along with the distributed V switch. When we make changes on one V switch, it can be automatically sent to the other V switches. The distributed V switches DVS automatically applies the change to the individual switch on each VM ESXi host. DVS is a licensed feature. This is a licensed feature, distributed virtual switch. So it is there available from 4.0 onwards. Here now we have 5.1 and so on, 5.5 VMware. Right. Distributed virtual switch. So this is the second type of, yes sir. No, it's going to be over, just a few minutes, sir. Is that okay? Yeah, so far what we have seen is only V switch. Now we are trying to understand why we need DVS. It's going to be over. Yep, in another 5 minutes it's over. Yep. So distributed virtual switching, it's a single point control, simplified network management because we got a cluster. Managing is easy. Removes the requirement for host level network configuration. Removes the requirement for host level network configuration, meaning I need not to go to each host and configure, which was there in the previous one. Removes the requirement of host level network configuration. I can centralizedly manage it with vCenter. Static and policy follows the VM, as we already discussed in the overall view class. When I move the VM from one machine to the another machine, the policies also move along with the VM. So statistics and policies follow the VM. Enables network resource pooling, meaning because I put all the hardware in one group, it is not seen as three processor, three hardware. It is not going to be seen as three computers, three servers, physical servers. It's going to be seen as one physical server. So if one is lost, nothing is lost. They're going to use the other two resources. So it's like, fabric here, cluster. So this is how it will appear when we have DVS. When we have V switches, three computers, three physical hardwares where three separate VMs or three separate ESXi, three separate. So we need to configure manually. But now because of VDS, we got all the three missions in one V switch, one group. All these missions are right here. I see as one single switch having all these VMs. Actually, these all VMs are not from single mission. Maybe these three from the first mission, these three from the second mission, these three from the third mission. But here it is very easy to manage because I see all in one page. one distributed virtual switch configuration. So it is easy. Multiple switch configuration using DVS is easy. Now all the NIC cards of various computers I see here as one group. So it is easy now to assign the VMs with the physical NIC as well. So what is special in DVS? We already saw that vSwitch supports trunking. It supports outbound rate limiting. It supports VLANs. But what it was not support is inbound rate limiting. Now that is supported here. Receive rate limiting. Now plus it also supports private VLAN. It also supports port state migration. Meaning when I move one VM from one physical hardware to another physical hardware, the policies and statistics also move along with it. So these three is newly added advantage or feature because of VDS. Right. So vSwitch and VDS. VMware VDS and vSwitch are not manually exclusive. Sorry, not mutually exclusive. They are not the same. VMware distributed virtual switch and virtual switch are not mutually exclusive. Physical NIC ports are assigned to either vSwitch or DVS. Separate ports can be assigned to vSwitch and DVS on the same VMware. So parallelly they can work, and we can have separate ports for vSwitch separate and DVS separate. Even when we have Nexus, we assign a vSwitch maybe to this virtual supervisor engine, and then virtual Ethernet module, VEM, virtual supervisor module, we'll put it in vSwitch, and we'll give separate NIC card, and we will put a VEM on DVS and put a separate NIC card to it. So both can be parallelly working together. As I already told you, for Nexus 1K, DVS is must. Alright, so this gave a good understanding about this 1000 means an introduction to 1000V. Before 1000V, how the distributed switches and V switches were and what they were doing, and we really went deep into it. The next chapter is about 1000V. So thanks for joining today. See you in tomorrow's class. Take care. Bye bye.